thank you all, including the, that's the attendees, organizer, and our team in India, Kryton BuildMat, for just, giving me this opportunity to share some information with you. As you know, that's our friends just introduced in the introduction mentioned, my name is Ali Reza, and I'm with Kryton International more than 14 years. And before that, that I did my master at university. And the reason I joined Kryton because my research was on concrete waterproofing. So, and before that, I was working as a consultant and contractor as well. So, and for today, I'm trying to, share with you some of the key points regarding to the making more durable structure based on my experience from the being a contractor, being the consultant, going to the university, and now working in the company that they produce some product and solution for make concrete structure more durable. And before I start, I really, that's wants to, that a speedy recovery for the some of the, that's the team that they already, that's get positive on the COVID. And I hope, that's the rest of the team and all of the attendees being safe during this time. And one of my requests that I know that because we are, attending at this time from different places, I really appreciate if you can mute yourself during the presentation. Now I'm going to just try to share my screen with you. Actually, Kryton is a Canadian company. Started in 1973 from Vancouver, Canada. And some of you may hear it from the Vancouver. A lot of people, they call it the Raincouver because you can say more than 200 days in the year we have a rain. A city surrounded by lots of rivers. And actually, always we are saying we have a water from side, up, and down. So that's why, that's establishing a waterproofing is not a surprise in Vancouver. And after that, you have to mention that in our company, we are just not manufacturing. We have one of the best, facility on the research. In our company, we are doing lots of research on the product development, and in addition, come up with a new solution and test method. And one of the test method that we developed during my present at the Kryton is a system that we can, that's evaluate the self-sealing properties of the concrete. And this is a very unique system. If you're talking about the Kryton International, is established in 1973, and we are so happy that in the world, the only place that, that they had the manufacturing is India. And the India Kryton BuildMat, they called Kryton BuildMat, established in 1966, look like 23 years after, that's Kryton International. And I think lots of these, that name and companies are very familiar for yourself. I was lucky that I visited India many times, and I was on the job site. And Kryton BuildMat started in 1960, and with the, that's most part of the India. And we have, distributor, applicator, and in addition, we have lots of client that some or all of you may have known. Lots of, that's a very familiar name. And so far, if you are saying that totally more than 2,000 project has been, finalized and finished and used the different Kryton solution and systems. And if you want to show you some of the photos, I can say it can be very familiar from residential. They can be from, that's commercial buildings, tunnels, and, that's for the new construction and even for the repair as well. Now let's back to the point of who is Kryton and what we are doing. I can say maybe in this presentation, I'm using the word of durability more than anything else, but durability and service life of concrete structure, they are very related to each other. And as a Kryton, we are specialized on providing a solution for making a structure last longer and become more durable. We have a very, that big range of the product. All of them, I can say, is focused on making a structure more durable. From the solution that we can add to the concrete as an admixture, from solution that we can apply on the surface of the concrete. And we have a solution for the joints and details in the structure. And we have some solution that used for improving the abrasion and resistance. But for today, mostly I'm focusing more on the two products, which is our two key admixtures. One of them they called KIM, Crystal Internal Membrane System. And in addition, another unique product, we call it HardSem, which is a admixture that we are adding to concrete to improve erosion and abrasion resistance. And our goal, that I really like the, that introduction, because they cover most of the material I am going to cover today, talking about the durability structure, why durability is important. And after that, the different type of the attack to the concrete that they can define to the physical attack. And what's our solution? And at the end, which is going to be my favorite part, how we can use this system and this material on the actual life, increase the life of structures. Let's start with the concrete. What's the concrete? And just thinking about the industry that we are working, how is big? So if you are looking for some statistics about the concrete, we should call concrete as the most man-made used material in the world. And we are producing and consuming concrete 2 times more than the other building materials. You can mute yourself, I will be appreciated.
So your voice is not audible. Can you unmute yourself?
So we are not able to.
Dear sir, we are unable to hear you. Please unmute yourself.
Mr. Ali Raja, your microphone is muted. Please unmute it.
ये चाहिए ये जो रख ली तो काम वाला इनका तो काम कर
Mr. Ali Raja, please unmute your microphone.
और यार वो लगा लेता हूँ चार्जिंग है कि ऐसे ही होगा लेकिन ये तो वो वाला है
Excuse me, can you hear me now?
Yes, please, we can.
Yeah, actually, I don't know how it's muted because when I'm getting to the presentation, I cannot see the rest. So in case if somebody by mistake and organizer, if they can check, please check that I don't get muted, please. Thank you.
So we probably, maybe we organizers didn't mute you, but somebody would have maybe. Or when you asked that it was not, somebody had not muted their microphone, maybe by mistake organizers muted everybody. Yes,
I
that's all.
think I muted myself.
So
And actually, when I getting to the presentation, I cannot see. I cannot.
So I would request you during presentation, if you move cursor on your screen, you can see the little bar. But we'll make from.
Appreciate, please, check that, that the organizers check that I'm not muted. Thank you so much. Pleasure. Okay, let's. And can you hear me now? Can I back to the?
Yeah, sure, we
Yeah,
can.
we can hear you.
Okay, perfect. And the last and the most important properties of the concrete is the durability. We consider concrete as a durable material. And durability is defined of the resistance of the concrete against different type of the chemical attacks and abrasion. But how much in reality concrete is a durable material? We consider concrete as a durable material, but at the word we can see lots of premature deterioration. So that's why, however, concrete has a potential to be a durable material, but for many, many reasons doesn't act to be a durable material. And the key part of our presentation today is to talk about how we can increase the durability of the, that concrete structure and reduce the chance of issue. This is some of the, that's information about how much of, that's our money we are spending for the repair of the premature, that failure. And if you look at the, that's the even developed countries, look like if you look at the UK, they are, that's repair and maintenance, they make up around 40% of all construction work in the UK. And even if you look at the, that construction budget, depend on the countries, they are spending around 3 to 5% of their, the GDP for the repair of the concrete structure. So it means how to concrete as a durable material, but for many reasons doesn't act to be to be a durable material. So, but what's the point? What's the key point on the durability? If we look at the key point on the durability, there is a two-part. One of them is a concrete. The second one is a weathering action or chemical attacks and abrasion. So that's why durability of the concrete depends on the two factors. One of them is the concrete by itself. The second one is the environment. When you look at the concrete, they can be ingredients, they can be what type of the material that we are using. And in addition, when you are talking about when this material or when this ingredient that we have, how we mix it together. And after mixing, how we place or cure the concrete. So, and all of these factors affects on the durability of the concrete. That's about concrete side. Regarding the environment side, so when you are making the structure, now your structure exposed to what? Exposed to the some type of the chemicals, is on the mountain, is exposed to the freeze-thaw, is in the environment that exposed to the abrasion and erosion, just you have some chemicals, they can attack your concrete structure. So first, talk about the chemical attacks. So if you are talking about the three main type of the chemical attacks, we can talk about the corrosion, sulfate attack, AR. Depend on the different countries. You know, that's in some countries we have AR, in some countries doesn't. But one of the deterioration system that we have everywhere is a corrosion. So that's why when we are talking about the waterproofing, durability, and sustainability, waterproofing plays a major role to make a durable concrete. Because when we are using we call it Bible in the concrete industry, they call it Neville book. He said most of the problem in the concrete happened because of the presence of the water. So it means if we can control the movement of the water, ingress of the water, so in this case we can, control the durability and sustainability of a structure. Another code is coming from the construction waterproofing handbook. They are giving this idea how much concrete water they can damage concrete structure. We call it water they can continuously damage concrete structure more than the war and natural disaster. So that's why a couple years back, I have a presentation in Lebanon about the economy of the concrete construction. And the topic of that presentation was water is the best and the worst friend for concrete structure. Initially, for making the concrete curing, but at the later stage, water is the most and biggest enemy for concrete structures. Now I'm going to, use some of the codes from the well-known standards in the world. If you back to the ACI 212 chapter 15, ACI 212 chapter 15, they talk about the chemical admixture for the concrete. And in this document, in the introduction section, we consider concrete, when we have a good mix design, well proportioned, concrete is a durable material and they can resist against, attack. So in this case, typically we expected that if I have a concrete structure, for example, basement, and my basement, exposed to the wet soil or even water they cannot pass through the concrete. The interior is completely dry and everybody is happy. That's a concept. But in reality, in this standard, they referred, however, concrete is strong material. Concrete is a porous material, and in addition, concrete is a permeable material. It means concrete has some porosity, but worse than that, these porosity are connected to each other. And when they are connected to each other, they are making some pathway for water. And especially if we have the water molecules under the pressure, they can pass through the concrete and they can damage concrete structure directly or indirectly. In addition, we have one big enemy for concrete. The biggest enemy for concrete is a crack. When we have a crack, water has that's easy pathway and easily they can pass through the concrete and they can damage concrete structure, the effects on the functionality and the durability of concrete structure. So that's something happen. Water pass, rebar is corroded and they can damage concrete structures. This is some of the photos I took during one of my consulting job for a project at the north of the British Columbia in Canada. This is a 20 years old structure. And as you can see, after 20 years, and the column, inside column, this is something you can notice. There is a sign of corrosion. There is lots of aggregate on the floor. So that's why this structure, they need a major repair. And one of the main reasons is because initially they didn't consider some factors that this water is contaminated and they can damage concrete structure. So that's why typically for two reasons we need to have the waterproofing system. One of them, keeping the water out or in, look like the case of tunnel. We need to keep the water out. For functionality, for the water tank, we need to keep the water in. But in addition, something is really important. We want to keep the water in or out and not passing through the concrete because we want to having the durable structure longer. What solution do we have? How we can reduce the water penetration through the concrete? Overall, we have a two system. One of them, we call it surface waterproofing system, or the concept is a very simple, applying a barrier against water. So if the water not touching the concrete, they cannot pass through the concrete. And the second one, we call it integral waterproofing system. Integral waterproofing system, it means improving the concrete integrally and make the concrete as a barrier. So that's a completely two different concept and ideas. Let's talk a little bit about the waterproofing, because always we are looking for solution when we have a problem. Why, some company, they start to, that coming with some idea about integral waterproofing, because they notice in many cases, surface waterproofing, they have some limitations. Overall, as I mentioned, the concept of the, that surface waterproofing is simple. And in my opinion, honestly, the concept is great concept. When water doesn't touch the concrete, they cannot pass through the concrete. It's a great concept. We call it membrane system. The membrane system, they can be used as a sheet membrane system or fluid applied membrane system. That, we call it additional. But when you look at the membrane system, even in this slide is very obvious. In most cases, when we look at the membrane, since we're relying on the membrane, unfortunately, we are not relying that much on the concrete properties by itself. So that's why we have a defects in the concrete and we are making the barrier. In many cases, because I'm traveling around the world, I deal with lots of contractors, different project consultant. And honestly, in one of my meeting at the Abu Dhabi, the consultant told me, when I'm using the membrane, I don't care about the quality of the concrete. Maybe he was very brave to mention it, but honestly, in many cases, the contractor, because they know there is a protection for the concrete, they don't care about the defects and some issue on the concrete by itself. But the problem started from when the membrane failed for different reasons. Why membrane failed? One of them is a design error. Can you notice any design error? Yes, I have seen many, many cases that the design wasn't right for the project. And unfortunately, because it was a copy and paste design, looked like they used for one project and completely copied for another project, which is not right. The second one, membrane need installation. And whenever we are talking about the installation, always we have to look at the human errors. Membrane, when there is a possibility of the human errors. But if you look at these two factors, still you can say back to the 30, 40 years, still even up to today, a lot of people, they use the membrane. Why people, they notice the limitation of membrane these days more than in the past? One of the main reasons is because of the membrane's limitation by themselves. Because when we look at the, that required service life today, mostly, that as our friend mentioned initially, these days, mostly we are looking for 100 years or even longer. But when you look at the membrane system in most cases, I can say in all cases, they are not last that long. So that's why how we can, rely on the part of the structure when the life of the membrane is not matched to the life of the structure. Always I give an example about this, and just, a little bit more tangible example is, for example, if you are buying the car, that very fancy, that car that they can speed up to 400 kilometers. But if the car has this, the brake that they can stop up to 200 kilometers, and more than that, it's become a, heated and doesn't function properly. Is it safe to drive that car more than 200 kilometers? No, because the brake is the most important part of the car. At the same concept, when you're talking about the waterproofing is the most important part of the below grade structure. So that's why these days the membrane, they cannot match their life with the life expectancy of the structure. Membrane fail, water they pass, and after that, unfortunately, in many cases, the repair, since the membrane is not accessible, the repair is becoming very, very costly. And to be honest with you, that's how the Kryton started and getting to the market. The owner of the Kryton and the founder of the Kryton was in the business of fixing the leaking basement that they didn't have a solution. So that's why he hired some chemists and they come up with this solution. So let's talk about, when we are talking about the chemical attack and the problems, that how Kryton, they can provide you more tools in your toolbox and they can solve this problem. Let's talk about the integral crystalline waterproofing system. The concept of integral waterproofing system is make against water and make the concrete as a barrier. So if you want to just talk about the chemistry is very, very simple. However, that's, as I mentioned, as a civil engineer, we are not very, happy with talking about the chemistry, but this chemistry is very very simple. When we are talking about the normal concrete, for making the binder for the cement, we are adding cement plus water. And as a result of chemical hydration, we have two main types of the crystals. There is some others, but the two main type are calcium silicate hydroxide, which is a main binder or main part of the glue, and calcium hydroxide. From the other way, I want to say calcium silicate hydroxide is a good boy. They make concrete stronger, and calcium hydroxide is a lazy boy. This is something doesn't affect that much good on the properties of the concrete, and they can easily leach out from the concrete structure. So let's talk about the concept of the crystalline technology. The concept of the crystalline technology is based on using the crystalline product and to improve the properties of the concrete, how they do the job. As you can see in this equation, I put a crystalline product on top of the arrow, and I have a reason. I didn't mention A plus B plus C. I put A plus P at the present of the C because of the crystalline product or Kryton crystalline, or catalyst material. As a catalyst material, they are not consuming during the chemical reaction, but they helping the speed and the different form of the that's chemical reaction happen. And as a result of this, you will see at the present of the crystalline product, still you have a calcium silicate hydroxide, still you have a lime or calcium hydroxide. It means crystalline product, they do not have any effects on the strength of the concrete. So as a structural engineer, the first question is asking, what's the effects of this product on the strength of the concrete? There is no negative effects on the strength of the concrete. This product, they are not reacting with the lime. Lots of product which is available on the market, and they call it crystalline product, they are silicate material, they are reacting with the lime. They react with this. But our product has a completely different chemistry. So this product doesn't react with the lime, and at the present of the cement and water, they give you calcium silicate hydroxide, lime, but in addition, they give you another crystals. That's a reason that this product, they can improve the matrix of the concrete. These needle-shaped crystals, they are unique because first, they are stable, look like calcium silicate hydroxide. The second point, these crystals, they are much finer than calcium silicate hydroxide. Stable look like calcium silicate hydroxide, they are much finer than calcium silicate hydroxide, and they are needle-shaped. So combination of all of these, they give this product to be able to interlock in each other, and they are making resistance against water penetration. So that's why this product, they are capable of resisting against water when they want to pass through the concrete. It means if you have a pathway, as long as you are block the pathway, water they cannot pass. Has exactly the same concept of the door. If you don't want allow anybody leave the room, just close the door. As long as we are closing the door, that's no. We are needle shape making the water molecule to pass through the concrete. So has this concept, water has a pathway coming at the presence of the cement and water, crystallization continue, making some needle-shaped crystals. And these making needle-shaped crystals, they can grow and they can make resistance against water penetration. So if I want to give you some ideas about this product is a powder. In the powder, it can come in with the, that dissolvable bag or just as a pail, and easily they can be added to the concrete at the time of the batching at the batching plant, or they can be added to the truck. So it means when you are using this product as an admixture, there is no surface preparation, there is no human errors. So that's why it look like other ingredient in the concrete, they added to the concrete. And as long as you are mixing with the, the concrete and placing your concrete is waterproof. So that's need to application, waiting to the right time for the application and other, that's headache as well. And something we call it this system as a smart system. This system has a very unique properties. And that unique properties, that's the word of the smart I started in 2010 based on the behavior of this product. As you can see these days, that in Kryton logo, you will see a smart waterproofing system. And that's coming from the, that's one of the study I did with Dr. Gupta, which is my. And when we did the study, we called this system as a smart system because if you look at the structure, the crystallization happen at the 3 stages. First, initial stage, as long as you're adding the water, mixing with the concrete improve. The second stage, when you are doing the curing on the concrete, by curing, we are increasing the strength of the concrete and we are increasing the water resistance of the concrete. But the most critical part of this system is during the life of the structure. Imagine, for example, this is the the part of your tunnel. This is the wall of the tunnel, and outside you have a hydrostatic pressure. When you have a hydrostatic pressure, water molecules has a more energy to penetrate. I tried to exaggerate. When they penetrate, since we have a water, since we have a crystalline material as an admixture, then we have a more crystallization. And as a result of that, at the positive side, which is at this side, you have a more resistance. So that's why this system, they can adjust itself based on the needs. But another beauty of this system is if you have a, the tunnel, you can get the required resistance at the wet side, but inside of the tunnel, your concrete, they can be, improved as well because of the humidity and curing and other things, they make your concrete, more resistance against water penetration. This is some of the ASTM at which compare the regular concrete and the concrete that they have a KIM as an admixture. And when we are comparing these two has exactly the same mix design. And the only difference that you will see, and the ICW concrete, you can see lots of these needle-shaped small crystals that can make resistance and they can block the pathway. We did a research with the University of Victoria recently, and based on that, we used the highest magnification, microscope in the world. And as you can see, on the bottom is a control. You can see the cracks pathway for the water, and comparing to treated and untreated, you will see when you are treating the concrete with the admixture, you have lots of this needle-shaped crystal that they can improve the matrix. So if I want to summarize this, section, we are saying typically in ideal way, we are thinking concrete is a hard material, but should resist the water. But in reality, concrete is a porous and in addition is a permeable material. The traditional solution is to use the membrane system, but the membrane system fail. And then they fail, and look like we call it house on fire. So what's the solution? I can say look like the easy pathway to make the concrete waterproof from day one. And that can happen by adding the admixture to the concrete, because they can improve the matrix of the concrete and they can make concrete, as a permeable solution. So there is a, that this product has been used, for many, many years. But not only that, we have tested this product on the different ways and different methods. One of the most well-known tests for evaluating of the concrete, different concrete, is a test method. We call it DIN 1048, which is a German standard. And in this standard, we are simulating the real life. We are making the concrete. We are applying the head pressure around 5 or 50 meter of head pressure, keep it for 3 days. And after 3 days, we are breaking the sample and splitting the sample, and we are checking the depth of the water penetration. And this is a very, that's common test method in the world. And this is a look like as one of the study, and compare the untreated with the treated. And as you can see, by using the water penetration, that's reduced significantly. But is it permeability, and reducing the permeability is the only solution that we need for making the structure waterproof? And my answer is absolutely no. And the reason is because water, they can penetrate in the concrete in another way that is much easier than the permeability, and that's a crack. So that's why crack is the biggest enemy for a concrete structure. But typically, crack is a part of concrete. There is that I had a professor that he said, for concrete, there is two things that always happen. Concrete get hard and concrete will crack. That's how we can describe concrete. But when the crack happen in the concrete, they can easily penetrate, and they can cause a corrosion and other defect on concrete structure. But what's the solution? One of the solutions that we have for making more durable structure is reduce the number or reduce the size of cracks. So that's why by controlling the shrinkage, different type of the shrinkage and crack tendency, if we can reduce the crack size or crack number, in this case, we can have a more durable structure. That's another benefit of integral waterproofing system, or KIM, because when you are adding to the concrete, that's another study has been done at the British Columbia Institute of Technology, and they compare, you will see C as a control and K as a KIM. When we are comparing this, the difference is very obvious. And based on this study, the result has been published. And you will see by adding the integral waterproofing system, the number and size of the crack reduce significantly. Another unique properties of the concrete, and when you are adding the KIM as an admixture to the concrete, it's self-sealing. The concept of the self-sealing is very similar to the concept that if you have a paper cut and body is able to heal itself when the size of when we have a small cut. The concept is very similar, because when we have a small crack in the concrete and water they pass through the concrete is able to heal itself without needs from the outside. But when you are adding the KIM to the concrete, you can improve the self-healing of the concrete. This is a study, again, all of this has been published. This is a study they compared untreated and treated concrete, and you will see when you are exposing these two structure on the certain period to the water, you will see treated concrete, you will see lots of area they completely healed by using the Kryton product. And this is one of the actual project. You will see initially after fill out the tank, they have some leakage, but over the time, the leakage stopped, and without any repair, that structure healed. So one of the innovation test method that we did, and the concept was very similar: making the crack, passing water through the crack, check the flow, and after that comparing the treated and untreated. And that's is the first setup we built at the British Columbia Institute of Technology and our company. And this is a water reservoir, water passing through the crack sample and flow measured on the some flow meters and information sent to the computer. As you can see here, it was one of the study that back to 2011. And as you can see, comparing the treated and untreated sample, the treated sample is a blue line. They can see the flow reach to the 0, but for the control or non-treated, flow reduced, but didn't reach the 0. But maybe you are asking why, that again, flow reduced for the control as well, because self-sealing is one of the properties of the concrete by itself. By adding the crystalline technology, you can improve these properties. So that's why if I give a, that quick summary about the KIM, or integral crystalline waterproofing admixture that we have, they can increase the durability of the concrete with the 3 different ways. One of them is prevent action, which is improving the permeability of the concrete or reducing the permeability of the concrete. The second one is reducing the chance of the cracking, reducing the shrinkage and cracking. And finally, if in any crack happen, what's the final point is improving the self-sealing of the concrete. Combination of all of this, it means less repair and longer service life and is more sustainable. And overall, we can reduce the life cycle cost of the structure. Here is some of the example. Is the first project that they used KIM in 1983. Seattle, it's a city very close to Vancouver. And the first project, fortunately, they used the KIM on the tunnel. So that's a look like just exactly we're in the right place. And so far, after many years, is a dusty dry. Look like some of the other project. This is look like another project that they use the KIM admixture for the Shotcrete application. Another project for the precast application in the New Zealand. So that's a look like another tunnel part that they have used with the precast, and they used KIM for the precast. So that's why my point is the KIM is an admixture so that you can use it for the cast in place, precast, and Shotcrete application. For any type of the project that you have, you can use this material because it's an admixture. And this is one of the project in India back to the 2005 that they use almost 1,000 tons of the Kryton products for this project in India. And if you're looking for more information, my colleague and myself, we can provide you more information about this. And even this project, published in one of the, that's publication in India as well. This is another ongoing project. For sure, you are very familiar with this project. I visited the project at the initial stage. I supposed to come to the India early this year, but unfortunately, because all of this, I wasn't able to come. So this is one of the ongoing project that they use our product for this project in India as well. So that's why we have a solution that can be used for any type of the concrete structure. Now let's talk about the second system, which is we talk about the chemical attack and our solution for the chemical attack. How about the physical attack? If you look at the physical attack, we have 2 main types of physical. One of them is a freeze-thaw. The second one is abrasion. The quick one is a freeze-thaw. In part of the India, you have a freeze-thaw issue. So the freeze-thaw, the concept, and the factor effects on the freeze-thaw is very similar to the corrosion, sulfate, and AR is a water. Present of the water, they cause freeze-thaw because if there is no water, there is no freezing, and there is no damage to the concrete, the structure. And this has been tested even with or without another new research that we did with the university, even without air entrainer, when they use the KIM on the concrete, because they reduce the, the presence of the water, significantly reduce freeze-thaw issue. So that's why if you are comparing, even, I don't need to explain the photos, they can say, Freeze-Thaw, they can reduce almost 86% of the damage coming from the 100 cycles. And another one is abrasion. Well, what's the abrasion? Because when we back to the durability, in many cases, we are talking about the lots of factors effects on the life of the structure. Today, we talk a lot about the corrosion. We keep talking about the corrosion. In some local, that's for some area, look like in lots of Middle East country, we are talking about the sulfate attack because lots of soil are contaminated with sulfate. In Europe, in North America, we are talking a lot about the AAR and how AAR the damage structure. But honestly, one of the system that that significantly affects on the life of the structure, and unfortunately, a lot of people they are silent about that. They don't say much about it. Is the abrasion. Because abrasion they can differently, that's because based on the system, for hydraulic system or even for the manufacturing or even for the for the road that they use the concrete, because of the mechanical abrasion or abrasion and erosion, the base of the concrete wear, and after that they reduce the life of the concrete structure. The abrasion resistance of the concrete depends on the three factors. One of them is glue or hardness of the paste. The second one is the aggregate by itself, how much aggregate is hard. And the third one is how aggregate and the paste are bonded to each other. But typically, always you have to consider that if you have the concrete, for example, the aggregate is very, very hard, but they is aggregate, that they have a very weak bond to each other. For sure, you don't expect that structure lasts. So that's why, what's the solution? If you look at the typical solution and typical issues, look at here, in this structure, that's within 5 years, they reach to the point that is completely unsafe and they have to back and they have to do the full repair. And abrasion and erosion, the effects on the functionality, as you can see in the previous one. When the abrasion happen, even in the previous one is very obvious. When you have the abrasion, your rebar cover will become less and less. So that's why when the rebar cover become less and less, they speed the other deterioration system. And finally, the safety. When you look at here, what's the possible, that issue or factors that they can, they cause a safety issue even for the workers. So that's why finding a right solution for abrasion is very critical. I want to talk about the three common, that methods for the abrasion and erosion, which is the top three. The one of them is, if you look at the most of the textbook and, that's in instruction or guidelines or code, the most simple solution for abrasion resistance is increasing the strength. Whenever the chance of abrasion is higher, the code said increase the resistance. There is other system available on the market that they can increase the, that they can reduce abrasion and erosion and increase the resistance of the concrete. They call it dry shake hardener. And finally, the most simple one is using the liquid densifier. Even if I want to just, I'm going through this, but if I'm looking at these three systems, the high performance concrete, there is no question. In most cases, there is a good solution, but they have some limitation. And one of the limitation that has been stated in many, many researchers, and there is a lots of research about this, they talk about and they can improve onto the certain threshold, because if you are increasing a strength, when you are passing certain threshold on the strength, the abrasion resistance, they cannot change that much. So that's why when you are looking at the high strength concrete, in some cases they said in some cases more than 60 MPa, some cases that more than 45 MPa. At that time, by increasing the strength, you cannot get that much. And one of the problem that we have by increasing the strength, how we can increase the strength? solution, we have to increase the cement. So that's why the cost will be increased. By increasing the cement, another associated problem is look like we can increase the heat. So using the supplementary cementitious material, lots of research they shows. However, we can increase the strength, but on the other hand, we cannot get that much, that's return by increasing the strength, even by using the supplementary cementitious material. The second system is the dry shake hardener. This is coming from the ACI. You can see here, dry shake hardener, they have lots of limitation, but I'm going to just showing you this part. This is a ACI guideline about the finishing of the concrete. This is a chart that they explain. When you are going to place the concrete, if you have the hardener or pigment, you have to do all of these steps. And if you look at, last year I had a presentation at the World of the Concrete, and I asked some of the people, they already use the dry shake hardener. And I said, if you want to give me what's the top problem with the dry shake hardener, all of them mentioned using the dry shake hardener is very, very challenging. So that's why we have to consider it. In addition to the lots of other limitation, and that hopefully one day I have more time to just going through the whole that abrasion and erosion topic. But one of the biggest challenges is application. And there is a lots of limitation. They cannot be used with the air entrainer concrete. They cannot be used with the, lots of supplementary material because of the effects on the, building. They should be used just for the flat area. They cannot be used for decline or, horizontal surface as well. So that's why dry shake hardener, they have lots of limitation. And finally, liquid densifier. Liquid densifier, unfortunately, it's become quite popular in some countries, but if I want to call them and categorize them, honestly, I'm not even putting them on the abrasion and erosion, that solution. This is a product mostly are used for the dust proofing or just, increasing the strength of the surface of the concrete. And even if you back, there is a, that's one of the most well-known consultant. Even himself, as mentioned, even with the lots of limitation that we have with the, that's liquid hardener, they mentioned in today's concrete, you have lots of supplementary cementitious material. This supplementary cementitious material, they are using the lime. And this liquid densifier, they are silicate material. They need the lime as well. So that's why even these days, the effectiveness has become less and less and less. When we are talking about these three systems, said what's the alternative? What's the new solution? What's the new tools that you can add to your toolbox in case if you are reaching to the point that you want to increase the abrasion and erosion resistance of the concrete is the admixture. The reason we are just focusing a lot on the admixture because of the admixture. Using the admixture is very, very easy. Doesn't need the application. Doesn't need all of the challenges that we have associated with the application and other factors as well. This admixture easily they can be added to the concrete as a powder. You can add it to the concrete, and again you can improve the matrix of the concrete. So just make the paste of the concrete is stronger, and by making that stronger, you can see the difference. You can improve, but even in some cases you can improve up to 6. That's the wear resistance. In most cases, that we have done lots of study here. And even, by the third party that they shows they can improve, that's abrasion and erosion significantly. And in one of our recent study, we saw is more than 2 times. It means even if you have a structure that they should last for 20 years, you can extend it to the 40 years. So that's why this is some of the advantage that you can get. One of the unique, can say, properties of this material, it's a very, very natural material. When you're adding to the concrete, doesn't affect that much on other properties. doesn't affect on the water demand or setting time, or it can be used with any other admixture. There is no effects on the compressive strength or shrinkage. The only thing that you can notice, this material, they reduce the bleeding a little bit, which overall doesn't have any negative effects on the concrete properties. How much you need to add is around 40 kilogram per cubic meter, and that's that the fixed. So that's why when you're going to use this material, just you are adding 40 kilograms of this to the concrete and remove 30 kilograms of sand. So you are replacing 30 kilogram of sand with the 40 kilogram of this material, and then mix the concrete, and you're placing your concrete. As you can see here, compared to the previous one that I mentioned, dry shake, this is a very, that's quick. So as long as you mix it, there is no other, that's steps that you have to follow, and there is no dust and problem, and there is no chance of delaminations. Here is some example of the study, and that's there is a that the company that they have a very comprehensive study, and we compare it with the control. As you can see, Hardening compared to control, they improve more than 2 times. Has been compared with the well-known dry shake system, as you can see here, and some of them is quite expensive. Hardening, they improve the abrasion resistance more than others. And to be honest with you, in the past, one of my favorite study is not on the lab test, on the real life. And fortunately, we have one case study that they control and Hardening treated concrete, they applied on the project side by side. And after 14 years, you will see the difference. That's a real life. I think all of our test report in the laboratory, they have some limitation, but at the real life, we don't have this limitation. Again, if I want to just summarize anything about the Hardening, since it's the admixture, you can use it type of concrete as a cast-in-place precast shotcrete application. So, and in addition, they can be used with the air entrainer, non-air entrainer. It's compatible with all of the supplementary cementitious material. If you want to use it with the slag, fly ash, or other thing, is compatible as well. Now let's talk about my favorite part, because so far we talk about the some of the product that we have and how they works, but let's back to the part that and I really like the introduction. Hopefully that's his computer problem solved, or he can listen to us later, because he mentioned the one point that is very important. Look at here. We have a solution for the different type of the structure, for cast in place shotcrete, or that's precast application. Is it enough? The question is it enough that I fix, that's I improve the concrete by itself? First of all, you have to consider no, because when we look at the, that's some of the, that well-known codes and recommendation for design of the structure, I want to share with you some of these, that key point. First of all, there is a very important philosophy when you are talking about the below grade structure, or when you are talking about the, tunneling that you are working on as well. Let's compare, for example, for one structure, let's compare to the basement and waterproofing with the door and mirrors. For example, if after a couple years, that the flooring or doors has some issue, easily can be replaced, easily can be repaired. But when we are talking about the below grade structures, this is something is critical, because during the life, if anything happened to them, in some cases they cannot repair it. We cannot lift the structure and change the membrane system. And even if they are looking for some solution, those solution is very, very costly. So that's why this philosophy, they are mentioned, whenever you are going to design a structure, don't try that much to save on the waterproofing system. because later on you have to pay much more than that. So that's why when we are talking about the waterproofing design, we have to consider life cycle cost rather than initial. Because for doors, if you are going to cut from the, the cost of the building or anything, let's cost on the something that later on we'll be able to repair it or replace it. But for the part that is not accessible and the repair cost is significant, we have to look at the life cycle rather than initial cost. Another point, which is again is very important and it's coming from the British standard 8102. You do the design and then you are going to choose the material. Use the material, and again, I want to just refer to the introduction. There is a lots of product available. How we can trust? How we can trust to the product they do the job? Because there is too many products. So when we look at the product, always we have to look at the product they already approved by the third party or well-known third parties. That's one. And the second one, when you are looking at the waterproofing system, we have to consider a manufacturer that they give us the full solution. And this full solution, in many cases, we call it tanking system. I need a company that they give me all of the solution that I need to make my structure waterproof. So be back to this point. So if I'm going to waterproof the structure, not only I have to check this company, they provide me solution for improving the concrete by itself. Look like my concrete is less permeable, has a less crack tendency and more self-sealing properties. In this case, if the concrete works perfectly, but the water passed through the joint, the waterproofing failed. If the water passed through the tie holes, is failed. If the water passed through the pipe penetration, the system failed. So that's why when we look at the waterproofing design, we have to look at not only the concrete by itself, we have to look at the other accessories. I want to refer to another quote from the construction waterproofing. And now we are thinking how much these details are important. This called 90% 1%. 90% 1% rule is mentioned 90% of the problem happen in 1% of the area. So most of the problem happen in 1% of the area. And those area are the area that we are changing the direction or dimension. And that's area, it's the joint that we are going to discuss and the details. For this reason, Kryton, they provide lots of that accessories and other products, they do the job and they minimize water ingression or penetration through these details. One of the products that we have, we call it Krytonite. And Krytonite is a product that they swell when they absorb the water. The concept is very similar to the bentonite, but is a synthetic rubber. So it's, if you can see comparing these two after a certain wet and dry cycle, you will see. In addition to the material by itself, we design it on the trapezoidal shape because we want to improve the performance of the product when you are placing in the concrete. Another unique product that we have, we call it treatment. Treatment is, again, is a product that is in the powder form, include our magic crystalline material. And this product, when you are mixed it with the water, they give you a slurry. And this slurry, they can be applied at the joint, on any joint. And this product acts as a chemical barrier. When you are placing at the joint and you are placing the concrete, new concrete and old concrete, they are zipping to each other and they can significantly make resistance against water. So that's a very unique and is very easy to use product. Another product that we have for the joints and for other application for the as a detail, we call it crystal water stop grout. And crystal water stop grout is a product, they act as a physical and chemical barrier. This is the product. They already been, we already added fiber to this product, and actually this product, there is quite a durable material that can be used for patching and other purpose as well. So let's back to the, some of this detail briefly. For example, if you look at the construction joint, we have different ways or method is based on the limitation you can choose. And that's something, we are not providing the material, we are providing the solution. I said, let's discuss about your project. And when we know more about your project, then we can provide you solution based on your condition and based on the risk factor. Look, like as you can see here, we can combine the slurry plus Krytonite. We can combine a slurry with the grout. And if you are looking for, that high risk project and more resistance, we call it triple system, combine it slurry, swellable, and physical barrier. Other details, we have a solution, and for all of these, this is the application instruction, and this is the document, and this is the CAD drawings. Look, like if you are a consultant, you can have a copy and paste this information to your specification, and all of the information, even for a specifier and designer, is ready and include all of the details, which product we need to use and how they can be applied as well. If we have a construction joint on the wall to wall or a slab to the slab, still we have a detailed solution, CAD drawings that they explain the steps that they must be followed. Pipe penetration, based on my past experience in many cases, it's very, very challenging in most cases, especially if they change, that's the pipe location. If they want to just make some adjustment, it's become challenging, and we have a different solution using the swelling material or using the grout for the pipe penetration. Control joint is a very critical, and we have a product to give you a detail about how we can reduce the the size and number of random clack by using a proper control joint system. Unfortunately, in many that's design I have seen, they are not considered initially, but is under discussion. And when they know how much is important, they consider as a very good solution for minimizing the crack tendency. So far, I talk about the new structure, but how about the existing structure? If you have an existing structure, is Kryton has a solution? Yes, we have a solution, and we have a detailed solution. For example, if you have a tunnel, existing tunnel, it depends on the size of the type of defects that you have. Is a crack, pipe penetration is leaking, joint is leaking, you have some defects, or the concrete by itself, based on the aging, is weak. For all of these, we have a solution. If you have a even leaking crack, even if you have a very high hydrostatic pressure, we have a unique product. We call it crystal plug. That is after chiseling, we are applying this material. They fast around 1.5 to 2 minutes, and they completely stop. We consider this as a physical barrier, and after that, we are using our other product as a chemical physical barrier, and as finally as a chemical physical barrier on the surface as well. About leaking pipe penetration, we have a solution by using combination of plug and grout. We can correct it. If any joint problem, we have a solution, detailed information. One of the unique product that they can be used for both existing structure and repair as well. This, just for your information, this is the first product that developed in Kryton. It's a powder product. We call it Crystal T1. It's very rich on the chemicals, on our magic chemicals. So that's why it has a physical proper, chemical properties, because as long as you are applying on the surface of the concrete, they can completely penetrate through the concrete, and they can, because it's a catalyst material, they can completely treat the entire surface. And for this product has been tested in India, and they applied on the top of the 20 centimeters, that columns. And after that, by reducing the water, they noticed the, that's crystal, they completely penetrate to the other end. In addition to the chemical properties, they have a physical properties as well. As a physical barrier, they can resist against water penetration. Application is very, very easy. Just is a powder, you mix it with the water. And independent the condition, and dependent the size of the condition and limitation, they can be used by the brush on the surface, and for bigger project, or if you have, that access to the, that's a spraying system, they can be sprayed on the surface. This is one of the tunnel project that they, done last year in China, and in this, see that some leakage problem that they completely that the leakage stopped, and they use our leak repair system and our surface applied material for this project. Now let's talk about back to the one step back. I said you have a solution for concrete by itself. We have all of the other solution for joints, cracks, pipe penetration. Is it enough? If a company, they can provide you all of this product, this product by itself, they can do the job. And my answer is no. Having the product, they have potential to do the job is the first requirement. So in this case, you cannot expect that that a product that initially doesn't do the job at the end, even if the good application do the job. So, but if you have a product that has a potential to do the job, is it enough? Is it guaranteed to get a durable structure? And my point is no, because always you have to consider there is a difference between prediction and production. What do we predict and what we are produced? So I want to give you a little bit more tangible, as is I think that your time is close to the lunch time. Maybe it's not bad to compare the, that's a cake and concrete structure. Look, like in many cases, the people, they want to get this type of cake. That's, they have a recipe, they have information, they go and buying all of the ingredients, but at the end, there is a huge difference between production and prediction. The same thing for the concrete structure, we have the same thing. We consider concrete as a durable material. We have a good mix design. The material is good. The designer give me a good, information about, that even project environment, I use the supplementary cementitious material. But at the end, because of missing some point, we'll end up with the producing a undurable structure. But how we can minimize this gap? How we can minimize the gap between prediction and the production? For minimizing the gap between predict and produced, we need to look at the dream code. Dream code is a combination of action that we need to do to minimize this gap. If you look at this list, look like dedication, responsibility, expertise, awareness, models, material, manufacturing, control, curing, code, organizing, discipline, education. If you look at all of these, you will see that all of this is required if you are looking for durable structure, because if you are missing one of these, dedication or education, if you are not using the right mix design, it means a durable structure. If you are not using the right material, we cannot having the durable structure. If we have a perfect material, but we don't have expertise on placing of the concrete, we cannot have a durable structure. So that's why I back to the, that my master thesis, was my professor favorite part, Dr. Bantia, that he said, this is look like the heart of my thesis, because I compared the durability of a structure with the series circuit. If you look at the series circuit, when I have the, that's the light, when I have a source and I have some switches, if I want to turn on the light on the series circuit, if the switch 1 is on, nothing happen. 2 on is nothing happen. 3 on is nothing happen. So 3 switches on, but nothing happen. The only time I can turn on the light when all of the switches is on. This concept is very, very similar to the concept of the durability of a structure. For durability of the structure, concrete has a potential to be durable. So that's why we have a potential here. And for the durable structure, we have to consider different switches. Number one, mix design. Is mix design, is having the proper mix design is guaranteed to having the durable structure? No, but is required. We need to have a proper mix design to get a durable structure. We need to choose the right mix design and right material to get a durable structure. So that's why when you are doing the initial design, when we consider the environment factor, when we consider, okay, for this case, I have a sulfate, I have a chloride, I have a water. So that's why my concrete, they should be waterproof. And in addition, I have to consider chemical attack. So use the supplementary cementitious material, use the low water cement ratio, and use the waterproofing admixture. So is it guaranteed to get a durable structure? No, because the next point is this recipe should be used properly by a producer. So look like you have a good recipe for cake, you have a good right ingredients, but you need to have a good baker to bake it. So that's why production of the concrete, having the proper supervision for the concrete is critical. So if the engineer do the job properly, ready mix company may give you a good concrete, but when you are reaching to the concrete, but for any reason you are not placed the concrete properly, is it doing the job? No, because for example, I have a good ingredients, they mix it properly, but the temperature of an oven is not right. Can you get a good cake? No, because if you are putting the in the wrong temperature, you cannot get a good cake. The same thing when we have a good mix design, good production, and we are not compact concrete properly, then the concrete, they cannot be durable. Now let's think about, we consider all of this factor, good mix design, good production, and good placement. But if you are mix the cake properly and put it on the right oven, but you forget to remove it because somebody called and we talk, it's burning. The same thing, unfortunately, one of the biggest problem of the concrete structure, not to place the concrete, in most cases, we are missing this most critical point, which is a curing. Curing of the concrete is a guarantee that when you are placing the good concrete, you have to bake it properly, you have to cure it properly. You have to take care of the concrete properly. So in this case, having the proper curing is required. In this case, if you have a combination of good mix design, good production, good placing, and good curing, is guaranteed that you can get a durable structure. And there's something happen. If you back to the, I had one articles about, that when we look at the ancient type of the structure that they built, it was the accident. No, it was an accident. They have a system. And based on the system, when they work, now we have a structure, they last, that's almost more than 1,000 years or even 2,000 years. And just, for the finishing, I want to thank you all for attention. And this is for me and is a start, to, knowing you. But myself and our team in India, and including our nice managing director, Mr. Kapoor, that I visited him a couple of times, but he's a very great man. And the rest of the team and Mr. Singh and the rest, they are very, very nice guys. And we all are here to, that's working with you and providing with you whatever information that you need. Because in my opinion, construction is a teamwork. And for us, that's our key is to be helping to providing more information and giving you more tools in your toolbox, and see whenever that you are thinking our product and our system, they can do the job, we are more than happy to assist. And for the contacting us, easily these days you can Google it. And in addition, there is some more information about our, that's office in India. And thank you so much.
Thank you, Professor Elireza. Participants, any questions, query you may ask directly.
Thank you so much. I think your participants, they are very nice because they know that it's almost 11 p.m. here, and I think it should be close to your lunch time as well.
Yes. May I request to the participant for any questions, query?
Good afternoon, Anand here from Kryton, Mumbai.
Hi, how are you doing?
I'm good, sir. I have a question regarding surface applied technology, that T1, that how much penetration we can expect when applied, whenever we apply this crystal T1 from say positive or a negative side, how much penetration, depth of penetration we can expect?
Actually, that is a great question. And as I referred, that even the test has been done in India, and I think it's Shriram testing laboratories in India. There is no limitation. That's one point, because since this product is a catalyst product, as long as in the concrete you have the water and you have unhydrated cement and you have that's voids or just the pathway for the water they already reach, as long as the concrete is damp, this crystal they can penetrate. For example, if you have a basement and the basement is your concrete is completely damp, and even if you are applied from the which is inside, after the application they can completely penetrate and they can completely treat the entire thickness of the concrete. There is no limitation. Expectation is based on the requirement. Requirement is presence of the water. So whenever you have the water and unhydrated cement, this crystal they can penetrate. Did I answer your question?
Yes, sir. Thank you very much.
You're welcome. Thank you so much. Thanks a lot.
Hello.
Hi, how are you doing?
Fine. Thank you for your nice presentation. I have one question regarding the application of admixture. You mentioned that the quantity to be added is 40 kg per cubic meter. If this admixture is being added to HPC, then whether this is in addition to silica fume or that?
Yeah, it's a good question. Actually, this product is an additive. It should be added in addition to the silica fume. It's not the replacement of the silica fume.
Okay.
So you basically send the replacement. Right?
Thank you.
It's perfect. And it's 40 kilograms, you are replacing with the 30 kilograms of sand. So you are not changing the other ingredients. Did I answer your question? Excuse me.
Yeah, we can hear you. Yeah. Thank you.
You're welcome. Thank you so much. Thanks a lot. Hello. Hi.
Thank you.
You're welcome.
Any other questions, please?
So if there is no any further question, I just want to thank you all again. First of all, and thank you for all of the attendees, organizers. And I'm really happy, that's always I mentioned. I visited many countries, but for me, honestly, India is a second home. Whenever I was in India, it was my best experience in India. And I am really, happy to visit it again, and in addition provide any additional that's request for any project or activities. You can directly contact our team. At the same time, our team in Vancouver, we are working as a team and we are collaborating a lot, so that's why we are more than happy to assist for any specific project. And in future, if you are looking for more info, other products and going to the more detail, we are more than happy to provide more detail about the products application as well. Because honestly, based on 1.5 to 2 hours is not enough time to going through all of details. And on the other hand, I think I don't want to make you tired to, that's make it very long. But we are more than happy to provide further information if you need. Again, thank you so much. Thanks a lot.
Thank you. I express my sincere gratitude to all for participating in today's virtual training session on Smart Solution for Extending the Service Life. I'm very thankful to Professor Ali Reza for sparing his valuable time for conducting today's program. I'm sure all the participants will be benefited from his vast knowledge shared during the program. Thank you so much. Stay healthy, stay safe. Goodbye.
Okay, thank you so much. Thanks a lot.
Okay,
Thank you, Mr. Ali Reza. Thank you very much for all the participants.
Thank you so much.
And
thank you,
we
Mr.
at Kryton India, we are at your service and our contact details are there. And in any case, if you want any meeting, our team is ready to come and make presentation in your office also, and take on any query, and we can coordinate with Mr. Ali Reza on all technical details. Thank you very much. Thank you very much, Mr. Ali Reza. We have stolen some hours of your sleep, but you have made our day over here. Thank you very much for your time.
Thank you so much, pleasure.
Thank you all. Thank you.
Okay, take care. Bye. Bye.
Reza, it's very late in the night for you. So thank you very much for keeping awake and talking to us and sharing with us a lot of knowledge on the subject.
It's my pleasure. It's my pleasure.
Okay.
Thank you so much. Bye-bye. Take care. Bye-bye.
Sure.